videos for folks that miss what's going on. So vectors. So, and again, today is going to be mainly just about some vocabulary and a little bit of math on doing different forms of vectors and stuff like that, and different attributes of vectors. So all vectors have a magnitude and a direction. Magnitude is more than the length. That's all it is. It's just it's just a fancy word for length, but we always use magnitude, so it's nothing more than what the length is. Do remember, as we start finding it, it's always positive. Okay. You might see some weird questions sometimes where, like, you can talk about a negative magnitude vector, but it's really just a vector in the opposite direction. So magnitude, for the most part, is always going to be positive. And then the direction, the only thing we talk about with direction is it's just the angle in standard position, just like we did back in trig. It's the angle theta in other words, starting at the x-axis, the positive x-axis, and then going counterclockwise. So it's that same way we've been measuring angles forever. That should be safe position, not positive. And then we talk about vectors being in standard position. Not only the angle in standard position, but the vector is in standard position when the initial point or the starting point is at the origin. Okay. Now remember, and I say the start point, vectors are different from like lines or line segments, stuff like that. Vectors have a specific starting point and a specific ending point. That's why they have a direction, and the direction matters, right? So, you know, if you're going, as I said a minute ago, if you're going down the highway east at 50 miles an hour, that is a different thing than if you're going down the highway south at 80 miles an hour. You know, that you're going, that's a different thing. So the direction matters, the start point matters, and the direction you're going matters on all these things. Okay. Let's talk about notation for just 1 second. If you see, and again, if you're seeing like an assignment or you know, something on paper or in a textbook, usually we're going to denote a vector just by a single bold letter. If you see a bold-faced thing with these little pointy brackets, I never know what those are called, but they're not parentheses, they're not square brackets, whatever. These little pointy guys, if you see that, that denotes a vector. Okay, and it denotes a vector in standard position. So that means if you have a vector xy, that means that vector started at the origin and ended at the terminal point. And then the individual quantities, like the x, is what we call the horizontal component, because obviously it's going left and right. And then the y is the vertical component of that vector. 95% of the time, vectors are already described in standard position. So they're already going to have the little pointy brackets and be good to go and be good to work with. But sometimes they're not. Sometimes they're not. Sometimes you're given a vector that has a starting point somewhere else and an ending point somewhere. Okay. So if it's not in standard position, before we start working with the vector, you know, and add vectors together, we can subtract them, you know, we can do all kinds of operations with the vectors. But before we do that, we have to have it in standard position. Okay, so the way we do that is we do the end point minus the start point. The fancy name for end and start is terminal and initial. They mean the same thing, but always remember it's end minus start. You just subtract the x's and subtract the y's. Okay, so if my vector V has an initial point at 4, -7, and terminal point at -1, -1, how would I find what that standard position vector is? Well, you would do, again, subtract the x's, but it's always end minus start. So it would be -1 - 4. And then subtract the y's, -1 minus -7. And then just clean them up. So -1 - 4 would be -5. -1 + 7 would be +6. And that would be your vector in standard position. Okay, end minus start. The order matters, folks. And I'm going to say that about 100 times today and tomorrow. The order matters, because if you do it backwards, if you do 4 minus -1, you would get +5. And if you do -7 minus -1, you get -6. So the signs will be backwards, and it's obviously not the same vector because it's going in a different direction. Okay, so you got to make sure and get the correct order, end minus start. If you were to graph, and the reason this works, look, if I graph just these 2 points, and I'm just going to sketch this, this isn't going to be perfect by any means, but if I plot the point 4, -7 for like -7, so like down here somewhere, and the point -1, -1, so like that's over here somewhere, then the vector looks like this, right? So it goes from here to here. There's my direction, little arrowhead. But now if I move this to -5, 6, again, from the origin, -5, 6, it's like up here. So that vector, and again, pardon my gross sketch of this, but these are the same, they're the same vectors. They're just now in standard position, which is what we want. Okay, so we're basically moving the vector that we're given from 2 points, moving it to standard position, and that way we can do any kind of operation with it and still do and still find different attributes of the vector and stuff like that. Makes it easier to work with. So how about a different vector W? And by the way, I'm going to keep on using this vector V and W as we go through the rest of the notes today. Just so we don't have to do this thing over and over and over again. We'll just use the same vectors. So vector W, I'm going to give you about 60 seconds. If your initial point is -2, 5 and your terminal point is 7, 9, find the vector W in standard position. Again, same thing we just did. End minus the start. I'll give you about a minute. And again, watch your signs. The biggest thing I see all the time is just being careless with signs. You guys know how to do it. You drop signs like they're hot. So subtract the x's, end minus start. So 7 minus a -2. Subtract the y's, 9 minus 5. And then just clean it up. So W would be 7 plus 2. Be 9, and then 9 minus 5 would be 4. Done. Again, you won't have to do this very often. Most of the time, when we start doing like operations and applications and stuff like that, the vectors are going to be given to you already in this kind of notation. But if you're given 2 points, you need to know how to write that in standard position. Okay, so that's all about center position. Let's go into magnitude and then direction angle, and then we're going to call it a day after that. And then tomorrow we're going to get into the operations. How do we add vectors together, subtract them, multiply them, different attributes, and a little bit of different notation, and something called a unit vector. We'll do all that tomorrow. Okay, so magnitude. How do you find the length of a vector? Well, if I just do just a random sketch, and this doesn't have to be any specific vector, but any vector that I were to draw in standard position, you know, we know that would be xy. So that means my horizontal component, we talked about that a second ago. My horizontal component is x, my vertical component is y. So we can just use the Pythagorean theorem to find the magnitude. So magnitude is just the length of that vector. You know, how far is it? So the formula you're going to use to find the magnitude every single time is the square root of x squared plus y squared. That's it, every time. And the notation, and everybody always freaks out the first time they see the notation. It's just these double bars. Almost like I don't know, whatever you want to imagine those things are. The double bar, if you see the double bar around the vector, that just means notation. Okay, so if you see the double barred vector, that just means find the magnitude, find the length, Pythagorean theorem. Okay, so if I want to find the magnitude of the two vectors that I just worked with, that I just found, v and w, again, you just plug it in. So it would be for vector v, my x is -5, my y is 6. So it would be the square root of -5, bless you, squared plus 6 squared. And for heaven's sakes, please do not tell me that -5 squared is -25, because it ain't. It's always going to be a positive. So it would be 25 plus 36. So you can just leave that, when you add those together, it's 61. You can leave it as root 61 for all I care. You do not have to simplify the radical or give me a decimal. If you love decimal points and want to put it in Desmos, that's fine. It's about 7.81. But I am completely okay with just leaving it as a square root. This is actually better anyway. It's the exact answer instead of an approximate. Always the same thing, magnitude, square root of the sum of the squares. So if I'm doing the vector w, same deal. Let's do the square root. They're both positive here, so there's no tricks on this one. So 9 squared plus 4 squared is 81 and 16. And so that's the square root of 97. And again, if you want to put in the calculator, it comes out to be about 9.85. Either one's okay. Questions or comments? Maybe zoom out just a little bit so you maybe see a little bit more of this all at one time. Questions or anything we need to talk about before we go to the second page and talk about direction angle. And then as soon as I finish direction angle, I've got 2 more for I'm going to ask you guys to do on your own. To full blown. So like start with 2 given points, find the standard position vector, find the magnitude, find the direction angle. All right, so let's talk about direction angle. So the direction angle, and again, this is our old friend theta from the Greek alphabet. So how would we find the direction angle of any given vector? Well, we got to go back to trig. So you might be wondering if we're going to still use trig. The answer is yes. So again, if you just draw just a random vector in there somewhere, so I'm going to draw it in the first quadrant because it doesn't really matter. So again, if this is our vector xy, this would be my direction angle theta. It's always in that standard position, right, from the positive x-axis. So how do we find that? Well, if we know x, we know y, because we do, because we have what the vector is. Then we can use the tangent function. In fact, it's the inverse tangent. So again, it's the same formula every single time. So it's the tangent inverse of y over x, opposite over adjacent. Remember the old SOHCAHTOA thing. Okay, just like everything else, make sure you're in degrees, whether if you're using Desmos or whatever other calculator you're using, make sure you're in degrees when doing that. Now, super important point. I'm actually going to grab a highlighter so it shows up a little better. Super important point. This goes back into what we did a few weeks ago. I'm not going to get into the gritty details, but when you're finding the direction angle, please keep this handy and make a note of those 3 bullet points. Okay, because of the way we calculate inverse trig function when we're finding an angle. And again, because we're dealing with all 4 quadrants, a vector can be in quadrant 1, 2, 3, or 4. If your vector is in quadrant 1, then the calculator answer is going to be the answer. That's fine. If your vector is in either quadrant 2 or quadrant 3, you will have to add 180 to the calculator answer. Okay, and again, it has to do with the inverse trig, with the inverse tangent function, what the domain is, what the range is, stuff like that. We talked about that a few weeks ago. And if your vector is in quadrant 4, you're actually going to have to add 360 to the calculator answer. Okay, you have to remember that. If you forget that or don't do that, you're not going to get the correct answer on these kind of questions. Okay, so when you're doing a question like this, again, I'm going to use the exact same vectors that we had from that front page. So vector v was the vector -5, 6, and vector w was the vector 9, 5, 9, 4. Okay, so the first thing we do before we even do the inverse tangent thing, what quadrant are we in? So if we go -5 and then up 6, we're in quadrant 2. So keep that in the back of your mind for a second. When you put that into Desmos, again, it's always y over x, so it'd be 6 over -5. And you stick that into your calculator, and it's going to spit out -50.019. Now you're like, oh, okay, well, wait a minute. I'm in quadrant 2, so I've got to add 180 to that answer. So you just add 180 to it. And then you end up getting 129.81, which makes sense, right? Because we know into quadrant 2, it's between 90 and 180. So that answer makes sense of where that vector ends up being. And again, if you're in quadrant 3, you would also add 180. If it had been quadrant 4, you would add 360. How about vector W? Well, 9, 4 is just in quadrant 1. But to find the angle, we just do the same thing. So tan inverse of y over x, 4 over 9. But then calculator, 23.96. And quadrant 1, it's fine. You don't do anything. Because again, that makes sense. That's between 0 and 90. So we're good. And that'll be your final answer. All right, so what I'm going to ask you guys to do, I'm actually going to pause the recording for a second and let you guys work on this for about 5 minutes. Oh yeah, we got plenty of time. So here's 2 more problems basically for you. Okay, I got a vector A, initial point, -3, 2, terminal point. Remember, that just means start and end. And then a vector B with a start and end point. I want you guys for a few minutes to work on basically everything we just did. So find the component form, find the magnitude, find the quadrant, and then find the direction angle. Okay. I'm gonna give you guys about 5 minutes. I'm gonna hope to get some volunteers. Maybe, possibly. So when we are finding standard position, remember it's just end point minus start point, subtract the x's, subtract the y's. So this would be 4 minus a -3. And then for the y's, 0 minus 2. So it would be 7 for the x and -2 for the y. And that's your standard position vector. For vector B, same thing, right? 9 minus 14. -8 minus -1. So what's that? -5. And -7. -8 plus 1. What's that? I did. Thank you for the reminder, but I've already started back up again. But I appreciate the reminder because you never know. So now for the magnitude, once we have this, so we're done with the points. We are done with the points. Now from here, we're just using the component form. Okay, so for the magnitude, remember the double bars, that's our notation. So this, the square root of 7 squared plus -2 squared. So that's 49 and 4. And again, both of them are always going to be positive. So it'd be root 53. You can leave it like that if you really want to get a decimal. 7.28. For vector B, same thing. So that'd be 25 and 49. Which would, what's that, 74? Which is about equal to 8.6. And then the last thing, when to find the direction angle, first thing we should say is, okay, what quadrant am I in? If the x is positive, y is negative, we're in quadrant 4 there. And then we do the tangent inverse. It's always y over x, -2 over 7. Stick that into a Desmos. You get -15.95. But go back up to the notes real fast and say, okay, quadrant 4, got to add 360. And that'll come out to be 344.05 degrees. And last but not least, -5, -7, that's quadrant 3. Tan inverse of -7 over -5 would be 54.46. But again, go back to up to the nose for quadrant 3 is 180. So that's going to be 234.46 degrees. And those are your vector basics. What a vector is, remember direction and magnitude. Magnitude is just the length, Pythagorean theorem, direction, angle, inverse tangent. But remember, it depends on what quadrant you're in if you need to adjust the calculator answer. When we come back in tomorrow, we're going to talk about operations, adding, really just adding. There's really no such thing as vector subtraction. We'll talk about why tomorrow. And then something called scalar multiplication. Both graphically, won't spend a whole lot of time on the graphical part of it, but mainly the analytic and algebraic part of it and combining vectors. Okay, talk about that tomorrow. There'll be an assignment on Friday, kind of on the combination of the 2 days. And we will go from there. I'll have a PDF copy of the completed notes up there, and as soon as the video processes and I get it on YouTube, it will be up there as well. Okay, I'll be available for tutoring tomorrow morning.